Welcome. We're going to talk today about modulation and LFOs in patterning. And it's probably good to start with what is an LFO and what is modulation. So LFO stands for a low frequency oscillator. So an oscillator is just like a signal generator that makes a waveform like a sine wave. And a low frequency oscillator is a signal generator that's creating a waveform in the low frequency spectrum. It's not just a clever name, but what does that mean, low frequency? We humans can hear from about 20 cycles per second up to about 20,000 cycles per second, unless you are like me and have played the drums or something, and then you can maybe hear up to like 14K or less. But there's a range of frequencies that we can hear. Anything below 20 cycles per second, we can't hear as sound. We can't experience it as sound. However, we can experience low frequencies as like rhythm. Like for example, if I'm clapping at like 5 times a second, that's like a frequency of 5 cycles per second. I can hear that rhythm, but it's not fast enough to generate a tone. And so LFOs are commonly used in synthesizers and electronic instruments, drum machines in this case, to do what's called modulation. Modulation is basically when you're using one type of control signal to turn a knob for you, is the way I like to think about it. If you have like a pitch knob, and I could sit here and turn the knob once every second, or I can say, hey, I'm going to take a low frequency oscillator and I'm effectively going to have the LFO turn this knob for me, and we get this rhythmic repeating pattern of a parameter changing. That's using an LFO to modulate something. Modulate just means to change something, like basically using a control signal to change some parameter. Hopefully that makes sense. In patterning, we have these two LFOs that can be used to modulate parameters, and we can also use a random signal generator and the velocity as a modulation source, or the four things. So the LFOs are available on the layers page. That's the last of our 5 editor pages. We have layers, and then after that is LFO. The two LFOs belong to the drum kit. And so what that means is that these LFOs can be applied to all of the instruments in our drum kit, as well as the effects. And these settings will be applied to all of them. And so I like this idea because I can have an LFO that's changing the frequency, like the pitch of one sound, while it's changing the filter of another sound. We can make these LFOs modulate our drum kit, different parts of our drum kit together. So we have these two LFOs. Before I dive into the specifics of the LFO, let's actually set up an example so you can kind of hear what I'm talking about. You can see this LFO is moving back and forth, this low frequency oscillator. And I can apply that to any parameter in patterning. So let's take our hi-hat sound here. And a common thing to do, just for maybe not the most musical thing, but a really good way to hear this, is I can take this and apply it to tuning. To apply the LFO to a parameter, I'm going to just hold down the Alt key. And then when you hold down the Alt key, you see the different modulation sources: LFO 1, LFO 2, random, and velocity. I'll choose LFO 1. The Alt key is momentary if you just press on it, but if you drag off of it, it will latch. And so likewise, if I select the LFO and drag off there, it'll latch on so that I can see all the assignments. So I have LFO 1 selected, and you can see all of my parameters have been replaced with the mapping of LFO 1 to this parameter. So if I want to map LFO 1 to coarse tuning, I can do that with this fader, with this control here. So if I go up 35%, that means that LFO is going to modulate the coarse tuning of this sample. So let's hit play. And you can see on the parameter, the LFO, you can see how it's actually turning the knob, and you can also hopefully hear that it's making a change here. If I go back to my LFO settings, now we can kind of play around with this and hear how the different settings of the LFO control this. So our first setting that we want to talk about is the speed of the LFO, or the rate of the LFO. The LFO can either be synced to the tempo, which means that the LFO rate or frequency will be related to our tempo. Right now our tempo is 110 beats per minute, and I have it set to a duration of 1 measure. So that's going to be 1 measure of 4/4 time at 110 beats per minute. If I change the meter to 5/4 or 6/8, it will use that as my 1 measure marker. But I can go down to much faster, like 16th notes, and so on. Quarter notes. Dotted eighth note, dotted quarter notes. And we can even go all the way up to like 16 measures. And very slowly here it changed the tuning. Okay. So the duration or the rate of the LFO can either be synced to the tempo or it can be free. And in free mode, it's just going to use a rate between 1 cycle every 100 seconds, 0.01 hertz, up to 20 hertz, which is 20 cycles per second. Just for some variation, let's apply this to something else. I'll go back to my LFO 1. I'll double tap on this to clear that modulation. Also, just if you do have a modulation and you're not even sure like where it is, you can hit the erase tool and an X will appear next to any parameter that has modulation or automation on it, and you can just X that out to remove it. Let's go over to our mix, for example, and let's look at our filter. And I'll hit Alt, LFO 1 and put this on filter cutoff. One thing to point out with the way that modulation happens in patterning is when you trigger a sample, like when the timeline goes, when the circle goes around and you trigger a sample, the value of the LFO at that moment is captured, and it's called sample and hold. It takes a sample of the LFO at that moment and it holds that value for the duration of the sample. So if the LFO is up here when the sample is triggered, and that LFO is controlling the filter will stay at this level for the duration of that note. I like this. I think it's a more musical way than having the LFO smoothly like change everything. I kind of like this way of doing it, but these parameters are held at the moment of the trigger. And it's just like a design choice that I like, that I made, and you have to live with it. All right, so the next control is our wave shape. So we have sine wave, sawtooth wave, triangle wave, square wave. And then we have random, which is random stair steps. Each of these parameters, or each of these shapes, is going to have a different effect. So with a square wave, you'll see that the LFO just has 2 distinct, like a high value and a low value. So as that's modulating our hi-hat, we're going to hear 2 distinct filter settings that we're modulating between. Now, something that's kind of neat about this idea here is that, let me change the depth a little bit just to make it a little bit nicer. What do I want? I want this right here. Now, the LFO is not synced to the tempo of the song, so we're getting like an irregular modulation where the filter is going up and down, but not in tempo with the song. And that's like that's a cool idea. But notice how different that is. If I take my LFO and I sync it to, 1 measure, we're going to get level 1 for a whole measure, and then the other level for a whole measure. Similarly, if I choose like a sawtooth wave at 1 measure, we're going to get this ramp that's in time with our tempo of our song. Okay, so those are the main parameters for the LFO. LFO 1 and LFO 2 have the same set of parameters. And if we hold down Alt, there's actually a secondary set of parameters. We have offset, which is actually hard to see in this context. But when we're syncing to the tempo, we can offset sort of where the LFO starts. So if offset's 0, the waveform begins at the beginning of the song in tempo with the clock. If I offset it by 50%, the waveform is going to start in the middle. So when you hit play, it actually starts in the middle of the waveform, and so it'll offset what you hear from the modulation. And then the last setting here is called skew, and basically this changes the shape of the LFO, and it's a little bit different with each of them. In this case, it kind of bends this sawtooth wave, but with a sine wave, it does this kind of weird shape. With a triangle wave, it makes it actually go from a triangle wave to more of a ramp wave or a sawtooth wave. And then with a square wave, it does pulse width modulation, which is a pretty common technique in synthesis, where you're changing the amount of time it spends up and the amount of time it spends down. So with skew of 100%, it's going to be down all the time except for maybe just that one little bit there. At 50%, it's down 75% of the time and up 25% of the time. Great. So those are our LFO settings. Let me go back to a sine wave. And let me just talk about one more thing relating to modulation. So let me go back to our mix. And right now I have that LFO moving this filter for us. And when I hold down the Alt key, you can see we're modulating this way, so in a positive direction. Just for the sake of demonstrating this, I can also modulate in the opposite direction. And so even though this LFO 1 is applied to both the resonance and the cutoff, it's going to be moving in one direction for the resonance and another direction for the cutoff. So these two things are tied to the same LFO but moving in the opposite direction. So what you'll see is as the frequency of the filter goes up, the resonance goes down, and as the frequency of the filter goes down, the resonance goes up. Now it's actually pretty subtle because my resonance didn't start high. But you can see how the resonant peak goes up while the filter frequency goes down. Very good, very good. So I mentioned that the sampler settings, that at the time when the samples are triggered, they will hold the value for the duration of the note. The effects channel is different. So with the effects channel, all of the parameters are modulated smoothly. So this is nice if you want to create smooth LFO feeling. Let me actually go back to my hi-hat here and just turn off my modulation so that we're just getting our plain hi-hat again. And on our effects track, let's go to our EQ. So if I go Alt and I take my LFO 1 or 2 and I apply it to my high frequency gain, you can see that that is actually happening smoothly on this effects track. And sometimes I just like to go through and, play around with a bunch of these and I make a moving LFO or a moving filter. They're all kind of dancing in different directions. One thing that's cool that that we can play around with too is the delay. Let me make a blank new pattern. If I have a snare going and a snare that's sent to the delay, let's go over to our delay and turn that reverb send off. We can modulate the delay time. So let me just get this dialed in a little bit. Take LFO 1 and apply it to delay time. super weird. And, but we're getting this like repeating artifact of shifting the delay times by applying this LFO to the delay. So that's something I like to play around with modulating and the effect sends. Okay, so in addition to the LFOs, we have two other ways of modulating parameters. If you're on a parameter, so let's go back to a kick drum sound here. When I hold down Alt, we have our LFO1, our LFO2, and then we have random and velocity. So what random does, when I choose the random modulation source, you can see all of my parameters have distortion, mix, plus or minus. That means randomize this parameter every time we trigger a note. So if I wanted to say randomize the distortion overdrive, I can turn this up on randomize, and every time a note triggers, we'll get a new overdrive value. So this is a nice way of just generating some variety. One of my favorite techniques is to take like a hi-hat, go to my mix, and let's take our panning and go randomize and then panning. And now we'll get a random panning location for each of the notes. One thing to point out is that the panning plus or minus, you'll see that it goes from 0 to 100%. Panning goes all the way from left to all the way right. 100% means like that full range. So if you're in the center, 50% means it will end up somewhere between the far left and the far right. But if you're somewhere off center, you might have some things that end up off the edge, which means they're still going to be there. They're just going to be clipped to the far right. So that whole, a lot of times you don't need more than 50%, I guess is my point. 50% is, if you're in the center, that is the range to get to both outer edges of whatever that parameter has. So here's our panning. And we're just hearing every single note is randomized where it goes in panning. Fun thing too, randomized reverb send, I love. Just kind of adds a little bit of, some of those notes are going to get sent to the reverb and get sent out through that fake room. I like using this mostly in really subtle ways. I think it's really nice to have just like a little bit of this. Keeps my sounds alive and interesting. And it's a cool way to just get some variety. Oh, well, the other thing I wanted to say about random is that the LFOs, it's like one LFO and they're all applied to whatever you apply them to, the same LFO. But with random, it's a new random value for each parameter. Like if I have two different parameters on my hi-hat being randomized, the random number is different for each of them. So one might go up, the other might go down. It's not like one random value on that step. It's a random value for that parameter on that step. On the effects track, and I talk about the effects track in another video about the effects track in patterning 3. The randomization works a little bit differently. This is subtle but important, so pay close attention if you want to use randomization on the effects track. When you apply randomization to a parameter on the effects track, it will only trigger a random value on a step that you have a velocity on. So if I go to random and I apply it to delay time in seconds, a new random value for this delay time is only going to be triggered if I have a velocity on that step in the FX loop. So by putting a step on step 1, each time around the loop, we're going to get a new random delay time. So if I do also random on feedback and just like basically all these parameters, I could have just like a totally randomized, every measure I get a totally new delay effect by randomizing all those parameters. And it's just once the measure. If I want it to be slower, I can make my loop, longer, either by changing the step duration, like I could just have this happen once every, instead of that being 16th notes, it's now 16 quarter note, so it would happen a lot less often, which might be more musically interesting, but it always just depends on what kind of music you're making and what you're going for. Here comes a new value. I love that weird artifact that happens when it changes. So that's how we use random. And again, just the important thing to note is that on the effects track, you have to trigger the new random value using the velocity layer. Whereas on the other instruments, it's just going to happen whenever there's a note. The last of our modulation sources is the velocity. And basically the velocity is this, right? On our main loop, we're pulling out the velocity of a note, which is normally applied to how loud the note is. Let me make a new pattern, and let's do hi-hat pattern. It looks like I've got some randomization going on. Let me turn that stuff off. I've said this before, but if you have some you're seeing some modulation happening and you don't know how to turn it off, just hit the eraser tool and you'll get this little X and you can clear it. So you'll see that velocity normally is just, the loudness of the note, and it will continue to be that. But you can also map velocity to other parameters. And the reason this is useful is because it's basically like a macro. I can say, I want all of my notes that are louder to also have a different filter setting. So let's go to our filter like this, okay? And let's go velocity to filter cutoff. And now the louder notes will not only be louder, but the filter will also be opened up more. And so they'll be louder and they'll be brighter. And the advantage of this is basically that we're tying these two parameters together. It makes it faster if you have something set up to draw in like a dynamic beat. You can also, of course, type in the layer one at a time for the filter and the velocity, but this is a cool way to kind of make it a little bit more fluid and just tie the velocity to other parameters. I should also point out that that velocity layer is also quite relevant on the effects track, where there isn't velocity in the traditional sense of there's no trigger to make louder, but we can use this velocity layer to control a bunch of different parameters at once. So I could say this velocity is going to control all these EQ, all these delay settings at once, but there's also probably randomization on all of them. So, here's an interesting idea, actually. Let me turn that off. If we use our velocity layer to control a bunch of different EQ settings, you can see all these patterns are now moving according to this velocity layer. We're kind of controlling them all at once. And I'm underwhelmed by the actual musical result, but you'll probably do a better job than me when you sit down and try to figure this out. Okay, I think that's it for modulation and LFOs in Patterning 3. Leave your questions in the comments, and I will see you later. Happy patterning!